Alrighty, welcome back, boys and girls. I'll have to start the video like this. Unfortunately, I'm still under the weather, but we can always push through, make it the best effort that we possibly can, make mistakes on the way, recover, move forward as usual. So if my voice sounds different, or if I need to take a second to clear my throat, I will, and to make sure that giving you guys the best quality content you could ever ask for. So, we're going to be talking about independent and dependent variables, and we've used these words before. We've used these words in other subjects. And I believe you guys have used this in science, and you could already see it. The dependent variable relies on the independent variable, and what that's saying is the dependent variable is depending on it, so it relies on it. It's like that one thing that has to count on. Okay, so on this first part here, it says changing the independent variable is going to cause a change in the dependent variable. And I believe I've gotten this over the past couple of years that you guys know the dependent variable as the result. And so that's what we can keep using as an idea or something to reference. And so when we're talking about our tables and our graphs and our ordered pairs and things like that, you can try to ask yourself, which values am I going to have? So I'm going to have my x values, and those x values are always going to be the independent variable. It's what is put into the formula, or excuse me, the equation or the function. And specifically, it's the x is going to be the input. And again, we kind of keep that in part underlined because we're drawing attention to that main factor. And so there only leaves one other variable, which is y. And so y is always going to be the dependent variable, and that's the one that is coming out of that function. And so that's why we kind of get this phrase, the result, from this output. Okay, so if you need to pause this, copy it down, double check, make sure you're understanding and kind of seeing how this is working. All right, moving forward. So now, underneath of that, it has a couple of examples, and you can kind of see on your paper, it has independent variable, and then on the other side, we'll have a little bit of a spoiler, but dependent variable. But we'll take one at a time. That way, you're not too overwhelmed or anything like that. So the independent variable, excuse me, almost messed up there. The independent variable is the variable that is measured. Let's change that right away. Measured. There we go. Manipulated or selected. And what that's saying is that's the one that you are basing it off of. Okay, so that's what you're saying. Okay, it's the number of times I swept the floor, the number of tests that you have, whatever it may be, that's the input value. So that's what's going into your function. And that's the one that causes a change. Okay, so make sure you're thinking of the other pair to that. That's the cause and effect. And so if this independent variable causes the one that is affected, so make sure you're saying AFFECT for affect, and that's the dependent variable. So the independent variable, that's the one that causes a change in the dependent variable. Okay, so now there's a lot to kind of think about, but as long as you're thinking, okay, which one am I plugging into the function? Because we're always going back to that in part. Which one is going into it? Okay, it's the x value, and so that's the one that's going into the function. And then underneath of that, I have some independent variable examples. And as you're taking notes, in my class or other classes, I know World Geo does this as well, especially in high schools. If you need to abbreviate something, or if you need to write things down on the side, or on the margins, or you can draw pictures that help you remember. Anything that helps you take notes like this is always a good practice, because as you go through life, you're going to run into different cases where it's like you have to write, you know, a really important thing down, but it's on the back of a torn napkin. As long as you're writing it down, you have it, because the faintest ink is still stronger than the best memory. So I'll let that one sink in. All right. So some independent variable examples that you could have is like this. So let's say if your independent variable is the amount of time that you spend on your phone, what would that cause a change in? So we'll come back to that in a second too. So then another example would be the time spent studying. Another example is the number of pizza toppings. And then lastly, try to come up with your own. And once you see some examples here, you can kind of be able to create and make a independent variable and dependent variable pair that would kind of apply to you or make sense. So now let's see what's some other examples that we can have of this. So then on that right side now, you have that dependent variable. So that's going to be the variable that is the result. It's the output value. It's the value that depends on the independent variable. So this is the one that is changing, okay? And you can kind of think back to a couple of months ago when we were talking about independent and dependent events for probability. We had that the dependent events are the ones that change. So this is the value that is changing depending on this, okay? And we also said that the outcome, which is RY, that's the one that's changing both in the dependent variable and in the dependent events. So it's another kind of tie-in that you could have for this, and another good way to kind of make those connections for yourself. So now, as we're scrolling down here, it says we have some dependent variable examples. So now, if you're looking to think, okay, let's kind of isolate this a little bit. So if your independent variable is the amount of time that you spend on your phone, an example for your what is affected, and let me type that in so that way you guys know what word I'm using. Okay. And believe me, it's a stretch to go to the English side of things, but I try to make sure I incorporate that as much because it's the one that's affected, okay? And so you're kind of seeing, okay, the amount of time you spend on your phone affects your cell phone bill. So that, as the more time you have, the more your bill's going to be, okay? So try to think about how these interact with one another. So another example would be, okay, the time spent studying, that it should affect your test score. I can't stress this. I can't stress this part enough as far as studying, what you're studying, if it's actively studying or you're just kind of paging through a textbook while watching whatever, you're not going to get you're not going to do that well. But if it's quality study and practice, your test score will also go up. And so a third example would be the number of pizza toppings. So what do you think that's going to affect? What is that going to change on our right column? So that would affect the cost of the pizza. So obviously, it's going to, the number of toppings that you have, if you have more of those, the cost is going to go up, right? It would be we would like it if, the more things you got in your pizza, the cheaper it was, but that's never really the case. That's not a good way to run a business. So that makes sense too, right? Because as you're kind of loading it up, it's going to be a little bit more expensive each time. So now what I want you to do is, towards the end of this, make sure you have every little detail down. Make sure if you need to draw, pictures on the side to help you remember, I want you to write one of your own. So come up with either an independent variable or a dependent variable first, and then kind of make the pair from it. So maybe write on the left side, so write one of your own, and then come up with the dependent variable. So I'll give you a minute to pause the video and come back to that. Alrighty, so now on the back, to the back cave. So if you have, and kind of see this setup of items, you kind of see 4 or 5 lines kind of already making it. And so you've already written this table, and you want to make sure that you're getting used to saying it, so that way it's a lot easier to remember. So it's just like we had before. So we had our x values, and now already, if I'm kind of thinking, hey, I'm going to have another term that's like that, maybe try to remember for yourself before writing this down. So get used to writing this for yourself and not being relying on the video or something else. So be your x values, and then what else would it be? Yes, very good. It would be the input, it'll be the domain, and it'll be the independent variable. And so make sure also the key part to this is that IN. It's the one that's going into your function. And so that's why I write it in capital letters and I underline it. And then another term that I kind of have in there just to be helpful is that horizontal. So that's the one that's going left to right. So you're always thinking of these terms all together, and that's why they're all in blue. That's why they're all on the left side. All right, so now when you're making this table, it's a lot easier to make this left side because they're all associated. They all go with each other, and then you can just make the pairs. So if you have your x values, you're going to have your y values, and then as you go through, you can kind of think, okay, I have my input, I have my output, and what other options would I have? So try at this time, try to write in what the other lines would be. So I'm going to have my domain, I'm going to have my range, I have my independent, I have my dependent, horizontal, and a vertical. So you always want to be able to make this table for yourself. That way it's a lot easier to remember, and that way it's a good resource to have. So if you need to pause to double check, make sure you have everything, please do. Alrighty, moving on. So now, as you're reading through this, it can be a lot to read at first. So each time that you're faced with a word problem or anything like that, you never groan and say, oh, this is impossible, or whatever 12 million complaints that you can have. You always want to think, okay, let me break this apart so that way it's easier. So as you're doing this, if you need to, you can say, okay, let's cover up some of this. That way it's a little bit easier to read. That way it's a little bit easier just in general. All right, so the first example, so it says, it is getting close to the end of the month, and Joan is trying to figure out how much her cell phone bill will cost, represented as C. Each month, she has to pay $50 in addition to the 30 cents for each megabyte of data she used, represented as M. So you read through it once, you read through it again to yourself to kind of think, okay, this is what I'm trying to set up. And then after that, what you want to do is you want to make sure you go through and underline. So one of the ways you can actively read, as you read it once, to yourself, read it twice to yourself, taking a second, and then kind of say, okay, what am I looking for here? One of the ways you can help set this up is by actively reading. So it's either highlighting or maybe even underlining different parts that you can use that are specific to this problem. So as I kind of went through, I kind of said, hey, like I'm looking for the bill, and that's going to be represented as C. And so that's kind of two things I underline. I kind of need to use $50 in addition to, so I know I'm going to be adding. And then it says 30 cents for each. So when it says for each, it's going to be multiplying. And I'm going to be multiplying by m. And so now as you're doing this, you now think, okay, I can kind of formulate, or I can kind of put together this function. So step by step, let's do this. So it says identify the independent and dependent variables. So we know that, well, independence can be our x values. So what are we putting in? Well, we can say that it's going to be m is going to be our independent variable, which means that c is going to be our dependent variable. Again, that makes sense too, because for each megabyte m, our bill is going to go up. So as we use more megabytes, our cost is going to go up. So then it says write the function that goes along with the problem. And so still using that idea of how a normal equation is going to look like, we can set it up using different letters, different numbers instead. And so like I said before, we're going to have c is going to be equal to, since that's our output, and then we're going to have, since we said multiply, it's going to be that 0.3 times m, and I said there's going to be a plus in there, so it's plus 50. And so we're making sure we used each of those parts. And so we have that bill is going to be, that total bill is going to be that 30 cents per megabyte in addition to that $50 flat rate. All right, and so that last part is how much will it cost Joan if she uses 17 megabytes of data. And so now if it gives you, it usually will ask you this setup, it will ask you to label each of those things, come up with a function, and then it will give you one of those values. It might give you the dependent variable, it might give you the independent variable, it might give you both over two separate questions. So you have to make sure that you're reading each of those carefully. So I know that, careful now, I know that I'm going to let this 17, I'm going to let that be m. And so I'm going to have, let's set it up like this. I'm going to have my normal function, but instead of m, I now have 17. And we're always very careful because we're using those parentheses to show multiplication. So always, every time you replace those values, always use those parentheses. And so again, we're going to just be able to simplify this right side. And so we're going to do 0.3 times 17 first. And so we're going to have, if I can show it, there we go. We're going to have 5.1, which is that left side, and we're going to have plus 50, and so that's going to be $55.10. And so did that answer the question that we were asked? Well, it says, how much will it cost Joan? So yeah, if our answer is going to be in dollars, we know that we are good. So if you need to pause and reevaluate yourself, take a second, take a deep breath, make sure you have all this, please do. Alrighty, moving on. All right, so same kind of strategy. I'm gonna cover up some of this so that way it's a little bit easier to read. All right, so it says, example 2. All right, it says you're trying to calculate how often you have to take your dog for a walk. The amount of time represented by T between each walk decreased by 5 minutes each time your dog drinks water, represented by W. You also know that if your dog drinks no water, it will still need a walk every 60 minutes. Okay. For you, for those that have a dog, more power to you, because honestly, I can't deal with them. I don't like things that bark at me. So if you ask me to watch your dog, I'm going to say no. Then it says identify the independent and dependent variables, write a function that goes along with the problem, and then finally, how many times did your dog drink if you went on a walk every 30 minutes? Okay, so there's a lot to kind of get together, just like last time. So we're going to use that same idea, and we're going to have our active reading skills. And so to be able to do that, again, I'm going to have it underlined. And so I underlined each of the parts that I need. So when it says how often, it's going to be asking for a time, okay, because it's a frequency. It's saying how long does it take between each walk. And so we're going to say that since it says decreases, we know that it's going to be a minus. So it's going to, at some part in here, we're going to be subtracting by 5 times a number. And specifically, we know that we're going to be saying that multiplied, we're going to be multiplying by that W. Okay, so already right away, I kind of have some setup to our function. So if I scroll down, all right, so it says identify the independent and dependent variables. So we're saying that the one that is the outcome, so that's going to be the amount of time. So the amount of time is going to be our dependent variable. So that means that W is going to be our independent variable. And like I said, T is going to be our dependent variable. Again, I use those colors, blue and red, to kind of keep that theme going with our X values and our Y values. All right, so now it says to write the function that goes along with the problem. So we know we're going to have 60. We know we're going to have decreases by 5 each time. So we're going to have a subtraction in there too. And so when we go to set it up, just make sure that you're saying that this works out. So since our dependent variable is our outcome, that's going to be the one that's where the Y is usually at. So it's going to be T equals, and then we're going to have 60, and then minus 5W. And that makes sense too, right? Because it's saying that if they drank no water, it would need to walk every 60 minutes. So that means if I plugged in 0, meaning they drank water 0 times, this whole term would go away. And so all I'd be left with would be that 60. And so that's how we get that. That's how we get that right side there. So if this is a function, it's saying how many times did your dog drink if you went on a walk every 30 minutes. So it gives you, for this one, it gives you the dependent variable. So it gives you that T value. And so, there we go. So it gives you T, and so now I can plug in for the value that we know, and we have to solve now for W. And so it's going to be 30, and then minus 5W. So if you think back to more recent times, we now have let's see if we can find it. There it is, a 2-step equation. So how do you think you're going to solve this? Well, since we have a 2-step equation, we know we're going to have to do addition and subtraction first, and then we're going to divide by a -5. So again, all you had to do, subtract both sides by 60, and then divide both sides by -5. And so what you should end up with is W equals 6. And that makes sense too, because we have 6 times 5 is 30, and then 60 minus 30 would be 30. And so that kind of checks out as always. If you need to plug in your value and double check it, it will work. So if you need to pause, kind of gather yourself as well, make sure you have all the stuff down, please do. All right, so then lastly, just in case you maybe forgot or you weren't quite sure how I got that last equation, I just wanted to make sure that you guys had that option. So let's see if I can do this. Maybe not. There it is. Okay. Whew. All right. So if this is your 2-step equation, this kind of, as always, you can set it up. So if you need to write this on the side, or if you just need to watch and follow along, that's totally fine too. So I have 30 equals and then 60 minus 5W. So I kind of wrote on the side here, I said all right, we're going to need to subtract by 60. And so I'm going to have subtract 60, but whatever I do to one side, I have to do the other. So I'm going to subtract by 60 over here as well. And so what that leaves us with on the left side is going to be negative 30 is equal to, and then we're going to have the negative 5w. Again, our 60 minus 60 cancels out, and so this is our new equation. If this is our one-step equation, what do we say we have to do? All right, well, we have to divide both sides by negative 5. And so on the left side, this is what it's going to look like. Same thing on the right. So now if I, on the left side, what should I be left with? Well, I should be left with, I'm going to type this in actually, in white. Let's do, since they have the same sign, it's going to be positive. And then it's going to be 6, and then equals, so let's do equals, oh boy, of course I'm making mistakes, but it's all good. There we go. And then we're going to have W. So let's move that up there. So I'm going to have on that left side, if I can get this away, there we go. Whew. Anyways, so I did negative 30 divided by negative 5, same sign, means it's positive, is going to be 6. On the right side, I have negative 5w divided by that coefficient, as always. Again, the same number divided by itself is going to be 1, so 1w equals 6, which is exactly what we had in the previous slide, and so we are good. Again, if you need to pause, write this down for yourself, or include those notes on the side or a different piece of paper, please do. Just a quick reminder for your setup. All right, boys and girls, thank you for watching. Be sure to slam that subscribe button, and I'll see you next time.